Gauss Seidel iteration method. Gauss Seidel iteration method means they will give the three equations. You have to calculate the solution for those three linear equations. Three equations must be non-homogeneous. For example, I am taking general equations in this method. A11 x1 plus A12 x2 plus A13 x3 equals to B1. First linear equation in terms of x1, x2, x3. Second linear equation, A21 x1 plus A22 x2 plus A23 x3 equals to B2. Next equation, A31 x1 plus A32 x2 plus A33 x3 equals to B3. Now, these are the given system of linear equations in three variables x1, x2, x3. Now, you have to calculate by using this method x1 value, x2 value and x3 value. And this system is a diagonally dominant system. Means every time you focus on principal diagonal elements A11, A22 and A33. These elements are more than the other elements. If it is not like that, then you go for the which one is in the first equation, which coefficient is more than the other coefficients. Means that is modulus of A11 is greater than modulus of A12 plus modulus of A13, greater than or equal to. Next, another one. Modulus of A22 is greater than or equal to modulus of A21 plus modulus of A23. Another one. Modulus of A33 is greater than or equal to modulus of A31 plus modulus of A32. Like this. Means if one coefficient is more than the other coefficients in like that in each and every equation. Means if it happens like that, that system is nothing but diagonally dominant system. Now, after calculating, I will choose here A11, A22, A33 are bigger coefficients. Now, for that purpose, I am writing here x1 equal to 1 by A11. I am writing the formulas. These are the formulas. By using these formulas only, we will calculate the next approximations. x1 equal to 1 by A11 into B1 minus A12 x2 minus A13 x3. This is the formula of x1. Next one, x2. Formula for x2. x2 equal to 1 by A22 into B2 minus A21 x1 minus A23 x3. This is the formula of x2. Next x3. 1 by A33 into B3 minus A31 x1 minus A32 x2. Like this you write three formulas for x1, x2 and x3. Now you calculate the approximations of x1, x2, x3. Means first approximation of x1, first approximation of x2, first approximation of x3. After completion of first iteration, second iteration. Second approximation of x1, second approximation of x2, second approximation of x3. Like that you calculate the iterations. That's why this method is called iteration method. Now, for calculating the first approximation of x1, put x2 equal to 0 and x3 equal to 0. Because in x1 formula, we have x2 and x3. I am taking x2 equal to 0, x3 equal to 0 as initial approximations. Then, first approximation of x1. First approximation of x1 means I am writing like this. x1 in open bracket 1. 1 first approximation. This is nothing but notation of first approximation. Equals to x2 0, x3 0 means first approximation of x1 equal to b1 by a11. Again, in the second approximation x2 we have what is that x1 and x3 is there. Already I got first approximation of x1. You use that value in the x2 while calculating the first approximation of x2. First approximation of x2, for that one substitute first approximation of x1 and x3 equal to 0 in x2. Then first approximation of x2 equals to 1 by a22 into b2 minus a21 first approximation of x1. a21 first approximation of x1. Like that you substitute all those values. Means we are getting first approximation of x1 and first approximation of x2. Then using these two values, you substitute first approximation of x1 and first approximation of x2 in x3. Then we will get the first approximation of x3. Like this, continue the above process until to get the last two approximations are same.